Okay, so 3.6, again, it's the last section in this chapter, and we'll have a test on Thursday of this week. So linear systems with or in 3 variables. Woohoo, isn't that exciting? 3 variables. So we're going to have an x, a y, and a z. We can do this. We can do this. It's way better than graphing, I promise. All right, so a solution to a system of equations in 3 variables is the intersection of the solutions in each equation. So again, we're just looking for one point. So this would be if we graphed it on that XYZ plane. We're not graphing it. And solving it graphically is actually not practical, which is one reason too that I'm like, for us to be able to solve it, like to graph on the XYZ plane, is not of huge importance at this stage. Yeah. Mm-hmm. Yeah, and it's so hard to graph. But they can be solved algebraically, which is using substitution, right? Algebraically is substitution and elimination. So we can use either of those ways to solve them, or a combination of both, actually. So in example 2, we're going to solve the system. Okay, so we've got these 3 equations. Since we have 3 variables, we should have 3 equations in order to solve them. Okay, so the first step is to group the equation into 2 pairs and eliminate some variable. Doesn't matter how you do it. Second, we're going to pair 2 equations and solve the resulting 2 variable system. And the third step is find the third variable by substituting the 2 known variables into one of the originals. All right, so if you look at these equations, which ones do you want to like group together and eliminate? The top 2? You could do the top 2 because the y's, or you could do the bottom 2. It doesn't matter to me. We just need to pick one that we want to go with. Top 2? Okay, so let me go ahead. I'm going to clear this and move it up so we can get the whole thing in there a little bit better. Okay, so our solution is at the bottom, just so we know like this is what we should get. If we make a mistake, we'll know we're wrong. It's like checking your answer in the back of the book. I'm trying to get you all to be more, to do that more often. Okay, so let's group the first 2 together. All right, so we've got x plus y minus 2z equals -9, and 3x minus y plus z equals 13. These were nice because then our y's canceled, which, I'm sorry, I thought I changed colors. Our y's canceled, so we have 4x, what's -2z plus z? Minus z. And what's -9 plus 13? Okay, so there's one of our equations. Okay, now it says pair 2 equations and solve the resulting 2 variable system. So let's pair the other 2 equations. Okay, so we're going to eliminate y in both of them. So then we're just down to an x and z in both, because that's what we're familiar with working with. Okay, so 3x minus y plus z equals 13, right? And then 2x plus y plus 4z equals 17. Okay, so then our y's cancel again. 3x plus 2x is 5x. Z plus 4z, so plus 5z. 13 plus 17 equals 30. Okay. So now it says pair the 2 equations and solve the resulting 2 variable system. Right. Okay. Because yeah, so now we're down to 2 variables. We have an x and a z, an x and a z. So we're going to pair these. We're going to bring these 2 together. So if we have 4x minus z equals 4, and 5x plus 5z equals 30. That is a 5z, not a 52. We could times the top one by 5. That'd be perfect. Okay, so if we multiply this one by 5, and we'll take it over here. So 5 times 4x is 20x. 5 times negative z, negative 5z. And then 5 times 4 is 20. All right, we're just going to bring the original one over here. So we have 5x plus 5z, because I'm lining them up, equals 30. Good job. So the z's cancel. 20x plus 5x, 25x equals 50, because 20 plus 30. Divide by 25. X equals 2. And we, right, the solution is down here. It's kind of, so we got the x equals 2 part. So we're on the right track. Woo, that feels good. Okay. Yeah, we can, since we already have x, we could plug it into one of these two. Absolutely. So you want to do the 4x minus z? Is that what I heard? Okay, so I'm going to take the 4x minus z equals 4, and I'm going to plug 2 into that. So 4 times 2, let's see, that's a 2 minus z. So then I've got 8 minus z equals 4. What would I do next?
Oh, sorry.
That's okay. Minus an 8, okay. So then I have negative z equals 4 minus 8 is negative 4. Divide by negative 1. Z equals 4. And is that what that says at the bottom? Check. So we plug both of those into one of the original. Which original do you want to use? The top one? X plus y. I like it. So x plus y minus 2z equals negative 9. Okay, so we're going to say, well, that's 2 plus y minus 2 times z is 4 equals negative 9. So we've got, I'm going to go ahead and 2 plus y minus 8 equals negative 9. Combine our like terms. 2 minus 8, negative 6. So negative 6 plus y equals negative 9. Then what? Add 6. So I've got y equals negative 3. So we've got there. And to write the solution, you do have to write it as an ordered pair. And it says down lower, it has to be x, y, z. So you have to write it in that order. So our x is 2. Our y is the negative 3, comma the z, which is 4. That is your solution. Questions? Is it as terrible as you thought?
No, just a few more steps.
Okay. Good.
It's just working, I'm lazy, I don't want to do it.
It's just working, you're lazy, and you don't want to do it. Fair enough. Fair enough. All right, let's clear this and flip over to the back. All right, so the top one is a graphic representation of the solutions because we're not graphing it. But I do want you to understand, so when we're graphing these, if it's on the XYZ, we're not graphing a line, it's actually graphing an entire plane. So if there's one solution, it's the planes intersect at one point. Okay. If there's no solution, it's because the no point lies on all three planes. So here, the planes are parallel, or here 2 are parallel and 1's perpendicular, but they don't all 3 intersect. If they have an infinite number of solutions, okay, the planes intersect on a line. So it would be this line down here would be the infinite number of solutions. Or the planes coincide. So like all 3 of these are the exact same plane, just like we have lines. But again, it's kind of a graphic representation, so you see like, oh, I'm graphing planes instead of lines at this point. Like we're looking at a planar system. So again, not anything that you really have to know or reproduce, but just to kind of get. All right, so let's look at this one. And our solution is down there. It's 4, 2, 8. But solve this system. Notice there are 3 variables in each equation, and so there are not. I'm sorry, I should say there are not 3 variables in each equation. So substitution might be helpful here. Not that you have to do it, but it might be helpful. All right, so how do we want to tackle this one? Yeah, not all of them have 3. Like this first one, right, doesn't have a z. And this one has a y and a z. And this one has x and a z. So yeah, this was a typo. Notice that there are not, there we go, 3 variables in each equation. But there are 3 variables. There's still an x, y, and a z. They're just not all in one.
So if we do solve for x in the bottom equation. Wait a minute.
Solve for y in the top equation would probably be easy.
If you solve for y in the top equation. Okay. Because the steps do say solve an equation for one variable. Because kind of like what the standard is. Then we're going to have to substitute and solve. And then we can use elimination to combine the new equation with the last original equation.
Well, if we use, I think, if we solve for y in the first equation, that y then plugs into the can plug into the second equation, which would solve for z.
Oh, I like
which
it.
would then just be put into the bottom equation, which would then solve for x.
Okay, so if we solve for y, then y can plug in here, which would solve for z, and then z would plug into here, and then we just have x. Okay, I like it. That's a good strategy. So let's, or it's like a good mapping out of what we could do. So x plus y, that's not going to work?
How's that not going to work?
Because if we put it in, we're going to have it in 2 variables in the second one. No, never mind. Okay, that could work.
Okay.
Go ahead.
Go ahead.
Yeah.
I was like, right, trial and error is the other thing. Sometimes we have to work them out. So if we solve for y, so subtract x. So y equals negative x plus 6.
See?
I see it now, yep. Okay.
But you
Yeah.
can't solve,
Okay.
either way you do it,
Yep.
you're going to have that issue.
Yep, I see it now.
He's right. So like when we plug this in, so we take this and we plug it into the next one. So we've got 3y minus 2z equals negative 10. When we plug this in, we're going to get 3 times negative x plus 6 minus 2z equals negative 10.
That
So,
would still work.
so here's the thing. So the problem is we're getting an x and a z now.
It would still work because then we have that x and the z for the bottom equation.
Yeah, so then we do have an x and a z for this equation. So, because either way, if you would have solved for x and plugged it into this equation, then you would have had a y and a z in the new equation that would come out into this one. So you're right. Either way, it still works. So let's distribute here. 3 times negative x is negative 3x. 3 times 6 is, okay, so positive 18 minus 2z equals negative 10. Oh, you forgot to distribute? Okay. Okay, well, let's get our like terms on the same side. So I'm going to subtract 18. So I have negative 3x minus 2z equals negative 28 at this point. Oh yeah, we could divide by negative 1, sure. So then we just have 3x plus 2z equals 28. Yeah, then we don't have all the negatives to deal with. I like it.
And then, so now we use that equation with the 4x plus 5z.
Yeah, so then we can use those together. So I'll bring down the 4x plus 5z equals 56.
Maybe we shouldn't have done the negative thing, because now it might be harder to...
Ooh, now it might be harder. Okay, we can erase. You want to go back a step and get rid of that?
Yeah. Because we just have to multiply by negative numbers.
Okay, so we'll just have to multiply by a negative number. Okay, I see what you're saying. So let's just leave the negative because we are wanting to eliminate them.
So,
Fair enough. I wonder if I
it's gonna
can
get
move my
some
whole
other way, but
equation. I cannot. All right, so let me write this up here. So then I've got maybe 4x plus 5z equals 56. All right. Like you said, it kind of sucks either way, right? Like, there's really no nice way to do this one. Okay, multiply the top by 4 and multiply the bottom one by 3. So we're trying to eliminate our x's, I'm assuming? Okay. All right, so then I'm going to write that over here. So 4 times negative 3x, negative 12x, 4 times negative 2z, minus 8z, and then 4 times negative 28. Negative 100 and not 2. Oh, wait, hold on.
No,
We did
112.
112. Okay. Can you confirm that, Ethan? Let's see. I think I did a different problem. Yeah, my setup is different than yours.
Negative 28 multiplied by 4.
Okay, I just wanted to confirm. All right, so then let's do the next one. 3 times 4x is 12x. 3 times 52, 156.
No, it's
Oh, 5z, 5z,
yeah,
5z.
Wait a minute.
I'm sorry, 3 times 5z. Thank you. And then 56 times 3 is 150, 168. Okay. Very nice. Okay, so our x's cancel. What's negative 8z plus 15z? 7z. Okay, what's negative 112 plus 168?
56.
56. So we divide by 7. And what does z equal? Okay, so divide by 7, and z equals 8, which is down there in our solution. All right, so we got one of them.
So now we have to put z in the middle equation. Could we plug in z and y at the same time in the middle equation since we both know what they equal?
But we don't know what y is. We just know that y equals negative x plus 6.
An equation?
Do you have to use elimination? Because I solved it, and I got all the right answers, but I didn't use elimination at all.
No, you could use substitution.
It would work the way I'm thinking. I can explain
Yeah.
it to you.
Okay.
So if we plug in what y equals, because we found out that y equals negative x plus 6.
Uh-huh.
If we plug that in and plug z in at the same time in that middle equation, we can figure out what x equals.
You could, but you're doing more work to figure out what x equals. Like you could plug z into your middle equation and solve for y there, or you can plug z in for this equation and get x, and then plug x in and solve for y here. So because that's the thing, there are tons of different ways to plug them back in. Like Ethan used all substitution and no elimination. But in the way that, like, to plug both this y and this z in would actually make it more complex.
Okay.
So, which route do you want to go?
We can just plug in the Z.
But into which equation do you want to?
That's what I'm doing.
Which one?
Just the middle one.
The middle one?
Just
Okay.
solve for
Yep,
y.
that's fine. Because I'm gonna go ahead and walk through it. So we'll pick the middle one. So we've got 3y minus 2z equals -10. Okay, so that gives us 3y minus 2 times 8 equals -10. So 3y minus 16 equals -10. Add 16. So 3y equals 6. Divide by 3. So we get y equals 2.
And then you can just plug that into the top.
Yeah, and then the top one is the easier. So x plus y equals 6. So we're going to say x plus 2 equals 6 minus 2, and x equals 4. And then again, you have to write it in that x. Remember, it always has to be an x, comma, y, comma, z notation. So 4, comma, y, 2, comma, 8, like it has a little down below. Okay. So I think the best thing then is for you to just start practicing. Like we walked through 2 together. They are pretty time consuming. So you'll notice you just have number 1 and then 11 through 27 odd. Okay, so just a few because they do take some time. And you can get started on those. Sorry, that was a teaser. I hope you didn't shut it off there, Brandon. All right, so there are also times when we have word problems. And so I do want to go through that. So we have the Premier League 21-12. I think it should be 2012. Anyway, soccer championship team earned a total of 89 points throughout the 38-game season, in which teams are awarded 3 points for a win, 1 point for a draw, and no points for a loss. The number of games won was 2 less than 3 times the sum of their losses and draws. Write and solve a system of 3 equations in 3 variables to determine the team's record for the season. Whew. Right, so there's a lot in here. So these numbers are just your final outcomes. Like these are what you should get when we're solving it. Again, giving you the answers there. So let's see. We earned a total. Let's break down what's important here. So we earned a total of 89 points throughout a 38-game season. All right, in which the teams are awarded 3 points for a win, 1 point for a draw. What's a draw? A tie. Okay, and no points for a loss. The number of games won was, so equals 2 less than 3 times the sum of their losses and draws. Yikes. Okay, so
Same thing as always. I understand it
until we get the word problems. I get it. So let's use, here's the thing. So let's use W to represent wins. Okay. L is losses. And the D is draws. So let's start with their season, right? They had a 38-game season. So we know they played 38 games, right? What were their options for those games? What could they do with the outcome? Win, lose, or tie, or win, lose, or draw. So 38 is going to be the sum of their wins, their losses, and their draws, right? Okay, so we kind of got, so this is the number of games. How about if we think about the number of points that they earned? Kind of, right? They earned a total of 89 points. Okay, so 89 equals
Oh, the sum of their wins and draws.
their wins. Okay, why do you say wins and draws?
Because those are the only ones where they would have gotten points.
Right, because they get no points for losses, but then, so it is the sum of their wins and draws. But they get 3 points for a win, so that needs to be 3W. And 1 point for a draw would be 1D or just D, either way. Nice. Okay. There's 2 of the 3 already. The last one is that really weirdly worded one, right? It's here. The number of games won. Let's go here. So yes, this is our last one. So the number of games won was, or that means equals. So we're talking about 1, so that's W, isn't it? So W equals 2 less. So we've got 2 less than, what's less than? Minus, so it's going to be 2 less than, that always goes at the end. Okay, then 3 times, so that's, and here's the tricky part, because it's 3 times the sum of their losses and draws. So it's going to be a quantity of, what was it? L plus D. Awesome. Yes. So writing the equation is definitely the hardest part.
Ugh. Gross.
Gross. It's true. Let's simplify this one. So W equals 3L plus 3D minus 2.
So we already, oh my gosh.
Maybe I should have wrote that over there, but right, this one is just simplified. So we already have W.
Yeah, but it still has 2 variables in it, so it doesn't really help much.
It does have 2 variables in it.
Well,
But remember last time we had 2 variables in it.
Yeah, but
we have W, but the top equation has the L and the D at the sum.
Ooh, so this one
So we could
actually,
plug W in for there.
yeah, because like check this out. Because this actually has all 3 variables in it. So yeah, if we change it to the other form, right, so let's add 2 and subtract W. Can we do those at the same time? So we can switch their sides. So this would be 2 equals negative W plus 3L plus 3D. So then we can combine these 2 together. Is that, are we seeing it? Okay, so 38 equals W plus L plus D, and 2 equals negative W plus 3L plus 3D. All right, so then we would have our W's cancel, and we would have 40 equals 4L.
oh no, my bad, I wrote it wrong.
Okay, that's okay. I was like, I make mistakes, dude. Plus 4D.
We can divide the whole thing by 4.
We could divide the whole thing by 4. I'm good with that. So 10 equals L plus D.
So out of our element P, we could,
Well,
Subtract
this,
L and solve for D. We can plug that into the middle equation and solve for W.
awesome. If we subtract L, so we're solving for D, we could plug it into here. Okay. So minus L. So 10 minus L equals D. We're going to plug that into this one. Let me change colors. So 89 equals 3W plus 10 minus L, right?
Wait. No, we should have plugged it into the bottom equation.
Plug it into the bottom equation.
Yeah.
Change of plans. Okay.
It's gonna be less steps.
It'll be less steps. Okay. So we want to plug it into this one.
Yeah, because then it's
So do you want to go in this form, the W form, or down here with the 2 equals negative W?
I'm putting it into the W one.
This one?
Yeah.
Okay. All right, so we're going to have W equals 3L plus 3D, and that's 10 minus L, minus 2. So W equals 3L plus 30 minus 3L minus 2. Oh, what just happened there?
L's
Combining like terms, the L's cancel. So W equals 30 minus 2, or W equals 28, which is correct.
Then we can plug that into the W into the second equation.
Okay. So W into the 89 equation?
Yep.
Okay. So we're going to take 89 equals 3W plus D. We're going to plug our W of 28 in. So 89 equals 3 times 28 plus D. 89 equals, what is 3 times 28? 84. Plus D, we subtract. So 5 equals D. All right, so check.
Now we can plug both of those into the 38 equation and solve.
We can plug both of those into the 38 equation. Okay, so 38 equals W plus L plus D. Okay, and so 38 equals 28 plus L plus D. So 38 equals, oh, sorry. I need to plug 5 in for D, because we know it. Erase. Okay, so try again. Plus 5. There we go. All right, so that's 30. 28 plus 5 is 33. Okay, plus L. We subtract, and we end up with L equals 5, if I could write. Because I wanted to subtract, and I didn't do it. I can't fit it on there. So L equals 5 again. Perfect. So what is the team's record for the season? So this one, you're not writing a solution, a pair, right? A solution set. You're actually like, give me a sentence. What's the team's record for the season?
28 wins, 5 losses, and 5 draws.
28 wins, 5 losses, and 5 draws.
That's not bad.
It's not bad. Yeah, it is pretty good.
I don't know if I'll be able to, especially if there's like word problems like this. I probably won't be able to figure them out, and will not have time to do all of them.
Okay, so there is a word problem on your test, like this, where you have to write the system. But you don't actually have to solve it. It's just practicing writing. I think if I look at that, I'll have to look back at it. Or there's maybe one where you have to write it and another one where the equations are given and then you solve it. But we have 2 days of review. And so like we'll get some review on there. I get that they're hard though. This one especially is harder.
Just, but with the homework and stuff for today, I
Uh-huh.
might not be able to get it done. We'll see.
Oh, okay, you mean tonight.
Homework.
Gotcha. I thought you meant on the test. I was like, we've got 2 days of review and time to spend on it, because I get that like writing that equation is difficult.
Brandon's gonna look at this at the start of the video and he's gonna have an aneurysm.
No.